Good morning, everybody. This is a short talk about robots on Mars, because Mars is spinning there above your head, and that's what the theme of today is all about. So this is a fairly short talk. I'm happy to take questions afterwards, or you can mooch around, and there's a orrery over on the side there, solar system, when we can talk about not just Mars, but other planets in the solar system if you so wish. So, excuse me a second. So I'm talking about Mars and Martians, or at least a couple of minutes of introduction. Then we'll be thinking about landers that have been on Mars and rovers that are currently exploring Mars, asking what have they found, and in terms of the next few years, what are the next steps? So there's always been a fascination with Mars throughout the centuries, throughout the millennia perhaps. I mean, most recently, perhaps you're a little too young to remember, but most recently there was War of the Worlds, for instance. Not necessarily the musical version, but the book and the film and the radio that got a little bit of a panic up when people thought that maybe Martians were actually invading the Earth. I prefer the musical version, that's a lot more soothing. But of course, if you're of a certain generation, you don't necessarily think of War of the Worlds from decades or centuries past. You're more likely to think, when you say Martian, you're more likely to think of Matt Damon than anybody else. But we should just take a second to think about what this actually means. 100,000 years ago, some humans were still living in caves. But now it is possible to build machines, put them on top of a rocket, send them to another planet, have them land safely, move around, and send back pictures like this. A high-resolution panorama taken from Perseverance. We're interested in what's there, not simply what rocks are there, but, for instance, is the water there? Is there any sign that water has possibly led to the development of life in the past? There doesn't appear to be life there now. All of the cameras on all of the rovers haven't seen anything going on that implies that there is definitely life around. But there is lots of evidence that water has flowed on Mars. There's evidence that there have been rivers, lakes, clouds, rain. And if there has been water, most scientists think wherever you get water, wherever you get enough energy from the sun, wherever you have all the right nutrients, life will find a way. So there's a great deal of interest in looking at what's on the surface of Mars, and as I'll say a little later, thinking where do we need to look if there is any life on Mars. So I'm not talking about all of the robots that have been to Mars. I'm restricting myself to the American ones, not because I'm pro-America, but simply because there's more information about all of the NASA landers and the NASA rovers than there is for instance, the Chinese rover that's currently on the surface of Mars. So the story goes back to the 1970s when there was a Viking lander. Since then, we've had a number of different landers and rovers on the surface. I'm not going to talk in detail about each of them because this is supposed to be a short talk, and I can only spare a minute or two on each of these. So there have been lots of rovers. I'll mention a few, just the ones in red I'll say something about. The first one, the Viking lander in the 1970s, and then Spirit and Opportunity, these two rovers that were arrived on the planet in the early noughties. Curiosity and Perseverance are very similar rovers, so I'll just talk about Perseverance, the latest one, which landed in 2020 and has been roaming around the surface for the last 5 years or so. So let's start with Viking. That's what Viking looks like. No, we didn't send Carl Sagan to Mars with it. This is just him in the desert with a mock-up of Viking, just to give you an idea of scale. It's about the size of a rather small car. This was just a lander. Landers are easy in the sense that you put them on the ground and you don't worry about any locomotion. If possible, you look around, you have cameras, maybe you have a little scoop to take a little bit of the soil, but other than that, landers are restricted. But I was still amazed back in the 1970s. I remember when Viking landed. I remember it being on the news. I remember when the first color pictures came back from the surface of another planet. And that, to me, was almost as exciting as the idea of astronauts going to the moon and landing on the moon and exploring the moon. The fact that we can send robots to another planet and send back color pictures of what the rocks look like, I thought was absolutely amazing. How do you get one of these landers or rovers to the surface of another planet? Well, you put it on top of a rocket, perhaps a surprisingly small rocket. To get a lander or a rover to the surface of Mars, you need a rocket which is much smaller, for instance, than the rocket was used to get people to the moon. That's the mighty Saturn V rocket, 3,000 tons of rocket, which was necessary to get astronauts to the moon. Mars, of course, is a lot further away, but you can get there with a much smaller rocket. Why is that? It's not about distance. It's not the fact that Mars is further away than the moon. It's all about how much mass you want to accelerate and get to that distant object. In the case of the Saturn V, it had to lift more than 100 tons into orbit. In the case of a lander or a rover going to Mars, they might weigh maybe 1 or 2 tons, something like that. And that's why you only need a relatively small rocket to get a lander or a rover on Mars. What happens when you get there? This is an indication of what's happened. It doesn't matter if it's Spirit or Opportunity, they're pretty much the same. Once you arrive at Mars, you've got to slow down. And one way of slowing down is to break through the atmosphere. The atmosphere is very thin, but you can still use it in a so-called aero-braking maneuver. Eventually, it's slow enough that they can deploy a parachute. It's still supersonic at this point. It's still going really fast, but the parachute will slow it down to the point where they can start to think, right, how are we going to get this on the ground? The heat shield is jettisoned, and the lander, the rover, is now inside that little pyramid. But how do you actually get it onto the ground safely? They decided to do it this way, the cheapest way possible, which is, not with rockets, airbags. You basically deploy airbags and then you drop it. You slow it down as much as possible, but you don't worry about soft touchdown. You just drop it from 10 or 20 meters up and you let it bounce. And you let it bounce. And you let it bounce. It doesn't matter if the wind is taking it a little bit sideways. It doesn't matter whether you've got it precisely on target. You can drop it from a fair height. And as long as your rover and your lander are securely inside that set of airbags, then you can just let it roll for as long as necessary. In this particular case, I think it bounced 28 times before it finally came to rest. Then you can deflate the airbags, and then you can start unwrapping it. Very clever design, such that as it unwraps itself, it automatically makes sure it's the right way up, because it's in a sort of little pyramid that when it opens, there's the little rover in the middle of that pyramid. The rover has to effectively unfold itself. One of the first things you need is power. You can get power from the sun if you have solar panels, so the first thing you do is unfold your solar panels so that you can start recharging your batteries. Once the solar panels were deployed, like a little dainty butterfly, in the middle there is a mast, and that mast comes up with a camera on the top, and just behind it, looking like a little table tennis bat, that's a little aerial that allows it to communicate with an orbiter, which will ultimately relay signals back to Earth. The command signals that tell it what to do, as well as the signals from the camera, etc., taking the images back to Earth. So it has a little look around, make sure it is the right way up, just in case. It has a little stereo camera, so it can judge distance. It can tell where the rocks are in front of it. Once it's safely down, ground control, mission control can send it a signal, say, everything is okay, start motoring off your landing pad. So it then deploys its wheels, it raises itself up, unwraps its wheels. Most rovers have 6 wheels to make sure that even if one fails, they can still move around. And then it trundles off its landing pad and prepares to explore Mars. It does a double check with its stereo camera of what rocks are immediately in front of it to make sure that it can steer around anything that looks too dangerous. So if it thinks that looks a bit bumpy, it'll stop and it'll turn and then it'll go round and then it'll trundle off into the distance. Spirit and Opportunity had a design that was, these have to last at least a few months, nominally, let's say 3 months, or maybe they'll last 6 months. That's what the designers intended. What is it that ultimately determines the lifetime of a rover? If you've got solar power, then in principle, you've got power, not necessarily forever, but you're not limited by any particular fuel on board. But ultimately, what kills a rover is the fact that if you can't recharge your batteries, then you have a problem. So this is a selfie taken from a camera looking down on itself. There's the solar panels laid out like a butterfly. When it's clean, you can see the solar panels and they'll be picking up sunlight during the day and keeping the batteries charged and keeping power in all the systems. But Mars is a very dusty planet. There's an awful lot of something that looks very much like the sand that we would get on the beach here, for instance. There's a lot of dust around, a lot of red dust, and sometimes that gets kicked up into the atmosphere and starts covering the solar panels. So this is what it looked like some months later. You can almost not see the rover itself because the dust on the panels is the same color as the dust in the background, and it almost looks like it's camouflaged. And this is a problem because if there's enough dust to stop the solar panels working, you can't charge your batteries. And if you can't charge your batteries, that's a problem because the days and the seasons on Mars are not so dissimilar than the days and the seasons on the Earth. But both Mars and the Earth, despite the fact that Mars is only about half the size of the Earth, they have a similar tilt of the axis, 20-something degrees, 23.5 for Earth, more like 25 for Mars. So they have similar tilt of the axis of the planet, which, as the planet goes around the sun, determines the seasons. So in a sense, Mars has winters and summers, much like the Earth does. And the rotation period of the planets are not so different either. Earth rotates in a little shy of 24 hours, and Mars rotates in a little longer than that, about 24.5 hours, but very similar. So the day-night cycles on Mars and the seasonal cycles on Mars are not so different. The temperatures, though, are very different because the rovers have to keep warm at night because on Earth we have an atmosphere, a blanket, a duvet to keep us warm at night. Mars doesn't have that, which means the nighttime temperatures can plummet. If you're really lucky, the summer daytime temperatures might be above freezing. They could be as high as 10 or even 20 Celsius. But at night, the temperature can plummet because there's a very thin atmosphere not insulating the planet. And temperatures can fall to below minus 100 degrees. The electronics on board a rover do not like being cold. If you freeze a rover, it will die and won't necessarily come back to life when you next warm it up. So it's absolutely imperative that the solar panels charge the batteries during the day so that at night you can run heaters to keep the lander and the electronics of the rover, etc., warm. And ultimately, that is what tends to kill rovers once they lose the sun. The last transmission from Opportunity, remember they were only designed to work for a few months, Opportunity actually lasted 14 years moving across the surface, but ultimately what got it was the fact that during a Martian winter there was a sandstorm or dust storm which covered the sun so that during the day they couldn't see enough of the sun to recharge the batteries. And if they couldn't recharge the batteries, they couldn't run the heaters, which means in a vicious Martian winter, the rover basically froze. The last transmission from the rover back in 2018, it landed in 2004, so 14 years later, this rover's last transmission was battery low, getting dark, and then we heard nothing more. So unfortunately, at that point, it died. But it had done sterling service way beyond its design parameters. NASA decided Spirit and Opportunity worked quite well. There's a little bit of a problem with dust covering the solar panels. What are we going to do for the next generation of rovers? They decided for Curiosity and Perseverance, they would do something slightly differently. They still have to get through the atmosphere in the same way, slow down and then parachute and then land, but they decided to use a different power source. Rather than using solar panels, they decided to use what is called a thermoelectric generator, which basically is a power source that will last for hopefully decades and doesn't rely on light from the sun. Let's see how Perseverance ended up on the surface of Mars. Similar to Opportunity, to start with, it needs to aerobrake through the atmosphere to try and slow itself down. So a heat shield protects it whilst it's coming through the atmosphere. There's Perseverance inside its heat shield, getting rattled a bit. Eventually, it slows down enough, a little bit of a jiggle, it can fire jets to try and steer itself to the right place. Then a parachute, just like Opportunity, a parachute slows it down. Still supersonic at this point, but now slowing down. Eventually, the heat shield can be jettisoned and Perseverance is dropped. Then some rockets fire to try and slow it up. You can't take this all down to the ground because it would kick up so much dust, it would choke everything. So the retros slow it down. It then steers to where it thinks it wants to land because it has downward-looking cameras. And when it's found the place that it was intending to land, it wants to get close to the surface but not actually touch down. And what they then do is very clever and rather audacious. They hover and then winch the lander down on a crane. The jets snap the cable, the jets fire off, and the crane flies off and crashes some distance away, and the rover is left on the surface of the planet. Its electric generator is at the back there, no solar panels because it doesn't need solar panels. And that's how Perseverance and Curiosity ended up on the surface of Mars. This particular long, slow pullback of this CGI showing how the landing actually happened, this is a reminder that, okay, you're exploring the surface of Mars, but if you've only got a handful of rovers, only about half a dozen have ever been on the surface of Mars, you've still got an awfully big planet to explore. Yes, it only might be half the size of the Earth, but you've only got half a dozen different vehicles to roam around looking at what it is you're trying to find, whether was the signs of water, for instance. You have to choose your landing sites very carefully to make sure that you've got a representative view of what is going on in Mars, or on Mars. So this is Perseverance and Ginny. Perseverance is the rover. Ginny, or Ingenuity, is this tiny little helicopter that it can see off to one side. You can see Perseverance, or Percy to his friends, is looking a bit nervously back and forth, making sure his little offspring is safe there on the side. How did the helicopter get to Mars? Well, the helicopter got there under the belly of Perseverance. But before we look at that, how did it take a selfie? These days, of course, if we want a selfie, we just hold up the phone, click, and we're done. To make a Percy selfie, it has to take lots of separate images. So the camera, which is on the end of one of its arms, is basically looking down and the camera is moving backwards and forwards. The circle there shows you that the lens is always in the same place, even if the camera is moving at different angles, to try and make this mosaic, which ultimately gives us the selfie that we've seen here. So we can't see in this particular selfie, but underneath the belly of Perseverance, there was a little compartment, which is where the Ingenuity helicopter was riding in. So there's the Ingenuity helicopter under the belly, and then it was dropped from that position, extending its legs until it was righting itself, and then Perseverance trundled away and allowed the helicopter to then fly. In this particular video, I'm not sure if the sound comes across. There's Ingenuity on the left-hand side. Perseverance has backed away and is videoing one of these helicopter flights from a safe distance. So maybe you can hear a little bit of wind, and maybe you can hear a hum. The hum is the sound of those helicopter blades turning. So you're listening to a spacecraft on another planet. Why would you bother taking a helicopter to Mars? Well, one, to prove that it is possible to fly on another planet. This is the first time, other than just landing on a planet, this is the first time we've actually flown on another planet. The idea of a helicopter is rovers don't travel very fast, and if you've got a helicopter, you can travel much faster and you can scout out what's ahead. It might be that there's a hill over there, but rather than have the rover go there and find, oh, I can't go any further, you can have a helicopter scout out the region ahead and decide, well, you probably ought to go to the left of that rock rather than the right because there's an easier passage over there. So the idea of taking helicopters to other worlds is something that NASA has been thinking about, and currently on the drawing board is the idea of this thing that looks like a drone, a little mini helicopter called Dragonfly, that they're thinking of sending to one of the moons of Saturn. Titan has got a very thick atmosphere, and therefore, unlike the very thin atmosphere of Mars, it should be possible to have a much heavier helicopter carrying much more scientific equipment. So although we have sent a probe to Titan, the largest moon of Saturn, it would be nice to fly through the atmosphere and explore more rather than just drop a probe into one place and then just have a very limited view of that particular moon. NASA in particular like the idea of engaging people with the idea of space missions. It might be taxpayers that pay for it, but they would like the entire population of the world to be engaged with the whole idea of sending missions and explorations to other planets, which is why they give away boarding passes, basically, to anybody that wants one. So when I heard about this, I asked for a boarding pass for Perseverance. The idea being you simply give your name to NASA, they collect all the names of anybody that's interested, and then all the names are then stored on a tiny little chip, and that particular plaque there is sitting on the back end of Perseverance. So at the moment, I know that my name is on Mars. And as Perseverance is wandering around Mars, I know that I'm going with it. It costs nothing. It costs NASA essentially nothing. All they do is collect the names, put them on the rover, and it adds a milligram to the mass of the rover, so it really doesn't make any difference to the mission, but it's great for publicity and it's great to get people engaged with the whole process. But you can still ask, quite legitimately, why do we bother exploring Mars? Well, partly because we want to understand that planet. It's one of our siblings in the solar system. We want to understand it better. We want to study its geology. Perhaps geology isn't quite the right word because geo refers to Earth, but you know what I mean. Study the rocks and study the processes that are going on. Study the climate. See what that tells us about the Earth, because it is sometimes thought that, well, maybe Mars looks the way it does, and maybe Earth will change in the future in a way which will mirror the way Mars has changed. Mars lost its magnetic field and lost its atmosphere. We think eventually the Earth will lose its magnetic field and lose its atmosphere a long, long way into the future. But in a sense, looking at Mars tells us something about what we have in store. And of course, one of the really big questions is, well, is it a dead planet? If water has flowed on Mars, then is it possible that there is water under the surface, even though we don't see oceans, we don't see lakes, we don't see rivers, but there's evidence that they have existed. So is there any water under the surface? And if water has existed on Mars, is there any possibility that life did evolve at some time in the past? And some people say we want to explore Mars for a precursor to human exploration. That's quite a big jump, because sending people to the moon is possible. Sending astronauts to Mars is a really technologically challenging mission. That doesn't mean it can't be done, but we really have to have the desire to do that. But in a sense, this is paving the way. As Perseverance goes along, it's taking samples, some of which it's keeping with it, and some of which it's leaving as a sort of breadcrumb trail, as it were. So there's a little vial that it's left behind it. It's collecting rock samples and putting some in sort of sealed test tubes, as it were, and putting them to one side. It's also taking samples of the Martian atmosphere, literally just open them up, sample the atmosphere, seal them up again. What we would like to do is not only have these landers and rovers do their own experiments, let's see what this is made of, what elements are present in the rocks, etc. It would be nice to get those samples back to Earth, because the laboratories on Earth are more sophisticated than anything we can put on 6 wheels and send to another planet. So we would like to get those samples back to Earth again. How is that going to be done? Well, one plan is to send another lander. There's Perseverance watching the lander come down. The lander comes down, Perseverance goes to meet it, and it takes its samples with it. It takes its samples that it's been collecting the last few years and transfers them over to the lander that's just arrived on Mars. There it is, loading up something like, 24 samples. What does it do with the samples then, now they're sitting on the surface? Well, it turns out it's loaded them into a small rocket, which then launches itself back into orbit. There's Perseverance watching it fly away. That goes back into Martian orbit, where it meets up with another craft, the samples are transferred over, and then that is transferred back to Earth. That's called the Mars Sample Return Mission. They decided that they would send Perseverance and start taking samples before they had got all of the funding they needed for the sample return mission. Now it looks like that might be in jeopardy. The idea was it would be funded jointly between NASA and the European Space Agency, ESA. It now looks like the funding for that might be jeopardized by a certain president who doesn't necessarily like the idea of bringing samples back from Mars. So we're not quite sure where we stand with regard to all the samples that Perseverance has been collecting. But what's the next step? I've been talking about NASA missions, but the next step is actually an ESA one, a European mission. The Europeans are going to have a lander on Mars, hopefully by 2028. This is what it looks like. It's quite small compared to Perseverance, and again, we're going back to solar panels. That will limit its mission, but okay. What makes this particular lander different from all the others is the fact that on the front there, we have this black box, and that black box is a drill. So we can run this rover to different parts of the Martian surface and then drill down something like 2 meters below the surface. If there is water under the surface, it is hoped that this rover will find it. This rover, called Rosalind Franklin, will essentially be looking not for life as such, but looking for evidence that there is subsurface water, which would be the first step for believing that there might be life under the surface of Mars. And I'm pleased to say that not only is this a European mission, it's actually being built in the UK. We are building this rover, Airbus UK. There's the people putting it together. Somebody ought to tell them that there's a wheel missing and that they've replaced it with a shopping bag at the back there, but I think they probably know that. So this is not quite ready, but you can see it's already well underway in terms of construction, and we're hoping, yeah, give them a wave, we're hoping that this will be on the surface of Mars by about 2028, if everything goes to plan. So don't think of exploring Mars as simply being something that the Americans do or the Chinese do. We are going to be involved in this in the very near future. So if I've piqued your interest, you can find far more information on the national sites of NASA, the European Space Agency, and the Chinese equivalent of the Space Agency, where you can find more information. I have a few copies of the slides of this talk, and I've been recording this talk, and I'll make that available to your teachers via Rosemary in due course. Thank you all very much.